Hello again, Copper Canyon Algebra 2, it's Miss Castro. So we are on the last unit for the Edgenuity Unit 9. So congratulations, you made it this far. So we're gonna look at the last unit, 9.6. 9.6 is a little more complex than 9.5. 9.5, you were just graphing sine and cosine, kind of learning the patterns for sine and cosine, and a little bit about period and amplitude. So today you're kind of combining a lot more transformations with your graphing. So in this particular lesson, we're talking about period change and phase shifts. Now, the thing that's a little confusing is they use phrases like period change and phase shifts, but these are actually things that we've learned in Algebra 2 already. Everything today is transformation based. So I've got a lot of vocabulary to kind of quickly go over with you, but all these phrases should sound familiar. Just keep in mind, they have different, more sophisticated words for some of these transformations, okay? So over here, we've already talked about your period. And so yesterday, or in the last unit, we talked about period really has to do with the length. How long does it take for your cycle to complete from going from center high, center low, center? That's one cycle, right? So in the last unit, we learned that everything was 2 pi, but now we're changing the game. Not everything here is going to be in lengths 2 pi, because guess what? They're going to do what we call a horizontal stretch or compression. That means they're taking your wave and either stretching it out or compressing it in a horizontal way. So I don't have anything fancy. I wish I had a slinky. That would have been awesome. But take a look at this shirt here, right? This little shirt, you know, it says whatever, October. You know what? Let's switch it. Let's make it say April. So here it is, it says April, right? So if you think about this shirt and you say, hey, I'm gonna stretch this horizontally, meaning left to right, watch what happens to the umbrella and the word April, okay? They get stretched out. So that's exactly what a period change is doing here. It's causing your wave function to either stretch out and get shorter waves or less cycles in a wave, or it's compressing it and making you have more cycles in your wavelength. So that's exactly what's happening with your period change this time. Horizontal stretch or compression. Amplitude. Amplitude is kind of the reverse of that. Amplitude has to do with how high your graph gets, right? So in this one, we talked about amplitude is half the distance of your total height, which is still true, but technically what your amplitude is doing is it's doing a vertical stretch or compression. So if you thought about your April sign here again and you were stretching it this way, look what happens to your umbrella. It gets long and skinny, right? That's the exact same thing that's gonna happen to your waves. You know, you have your normal wave that you had, but then if you start stretching it out this way, your waves are gonna get longer and skinnier. They're gonna look narrow. So even though it's amplitude, technically that is also controlling what we call the vertical stretch or compress, because it's stretching it in a vertical direction, up and down. Okay, so again, some of these things should sound familiar, but they're calling them amplitude and period, so just kind of get used to that, but it still really is a stretch in the horizontal direction or stretch in the vertical direction. Could also be a compression, right? You could also squash it. All right, frequency. Frequency is a word that's going to pop up here, but frequency means just what it sounds like. Frequent. How often does it happen? How many cycles are in a 2 pi length? Okay, so that'll come up in a few things. How often does it happen? Phase shift. Phase shift, again, it has the word shift, but you're like, what is that? Phase shift is going to control your movement. It's going to control the actual left and right movement of your wave. Now again, it's not stretching it, it's just saying, hey, I'm going to take this sweater and I'm going to shift it 2 units over, 1, 2, okay? So when you see your phase shift, that controls your horizontal movement, just left 2 and left or right to the 2 or whatever, something like that, just controlling your left and your right movement. So go ahead and put that there. And then midline, same thing, we kind of talked about midline a little bit, but midline is just controlling the movement up and down. How many units are you moving it up? How many units are you moving it down? That kind of thing. All right, so let's go ahead and get started. So again, high vocabulary. All these colored words here, they mean movement, and we've talked about that before. Left, right, up, down. Hopefully when you see this next example, you guys will be a little bit more used to it and say, oh yeah, I remember Miss Castro taught us that. I'm a big fan of color, so if you guys have highlighters or colored pencils, crayons, whatever at your house, I highly recommend that you use them here. Also use pen and paper. You know, it always helps to write stuff down. But let's go ahead and take a look at my model, and then we'll take a look at a couple examples. Nice thing is, not a lot of math involved for the most part. There is a little bit of calculation, but not much. It's really just describing. All right, so here we go. This is our transformation model for trig functions. We're just looking at sine and cosine today, so again, not a whole lot going on there, but making sure that you know what all these parts stand for. So transformations. This is pretty long and kind of maybe intimidating, but each little piece here represents some sort of transformation. So we're going to go through everything one at a time. So let's take a look at the very first thing. So a lot of your things are going to say y equals. Edgenuity tends to use y equals instead of f of x. Not a big deal, just whatever. Look at the very first thing that pops up here, plus or minus, okay? So I'm gonna highlight the minus sign there because remember, anytime there's a minus sign in front of your function, remember what that actually does to your function. It doesn't really move it left, right, or up and down, but it causes what we call a reflection, a vertical reflection, right? It takes whatever you have and flips everything upside down. Just like the highs and the lows, right? I said if you have a high point but you have a reflection, it's going to completely make it the opposite and make it a low point, right? So just remember that, reflection. So this is a reflection. I can spell reflection. Those are not too bad. Most of the time you can spot those right away. Just look as, oh, negative, it's going to have a reflection. Everything's going to flip. Okay, so watch out for that. If you see a negative sign, that's what that does. The next thing is the A value. Okay, so your A value, once again, very related to your amplitude here. In fact, that's probably why they call it A, right? So your A is your amplitude. So I'm going to write amp there, but I'm also going to write underneath it the actual, what it means to us. They're calling it amplitude because this is a trig function, that's the proper name for it. But remember, amplitude is actually controlling a vertical or a horizontal stretch or compression. So that's what it's really doing. So I'm just going to say vert, stretch, compress. I'm just going to write comp. Okay? It's doing one of the two. It's taking what you have and either stretching it out long ways or compressing it, making it short and fat. It could be a lot of different things, right? So that's what the amplitude actually does. So when you see phrases like vertical stretch, vertical compression, it's really your amplitude and you're just deciding if it's stretching those waves out, making them tall, or if it's compressing those waves out, making them short and wide. Okay? So again, look out for that because it is the amplitude, but it is technically a vertical stretch or compression. All right, sine is just a pattern. So we talked about that last time. Sine would be center high, center low, center. So hopefully you've got that memorized by now. Let's take a look at the next part though. This part right here, your B value. The B value has to do with your period, but it's not actually your period. It's what we call the frequency. Okay, so this B value has to do with your period, but I want you to keep in mind, this has to do with your period length. Okay, it's not your actual period, but it has to do with it. In fact, I have some formulas over here. I don't know if you guys can see them. Period is actually 2 pi over your frequency, but we're going to be using this quite a bit here, your B value. Okay, so this is really your frequency. Maybe I should cross that out. Let's put frequency. And remember what I said, your period is actually getting changed here. That's why the lesson's called change in your period. So when we take this, we're actually doing a stretch or a compression, but in the horizontal way. So let's go ahead and call this horizontal, I'm not gonna write the whole word out, it's too long. Horizontal stretch compression. Okay, because again, what it's doing is it's taking your graph and either stretching it out this way or compressing it this way, right? It's either stretching it out, making nice wide waves, or it's compressing it and making the waves like repeat themselves more. It's kind of making a lot of zigzags, right? So they're both different, but in the sense that they still control the stretching and compressing in different directions, okay? If I were to squash my waves this way, I would force more waves, right? In my period. So again, that's what that B value does. It controls how many cycles you make in a certain amount of distance. Are you making a lot of cycles because you compressed it and made a lot of it happen? Or are you stretching those cycles out and making it, you know, not so many cycles in your length? All right, now the next two should be very familiar because this is where we spent a lot of time in the past. All right, so right here on the inside, notice I said inside again. Right here on the inside, if you remember anything I taught you guys from transformations in the past, inside is always opposite, right? And not only that, I always say, you know, it's always in parentheses on that inside part right here where this H value is. And so remember, what that really does is it controls your left and your right movement. So these are horizontal shifts, meaning they're just moving it left or right. They're not stretching or compressing, it's just like actually moving it over left or right. Okay, so this is a horizontal shift, and I'm going to go ahead and write next to it left, right. Remember, everything in here is opposite. Okay, I wish I could fit that in there, but I can't. So everything in there is opposite. So even if you move, you know, if you feel like you're moving over to the left, it's actually going to have a positive sign because that's backwards. We'll see some examples here in a minute. All right, and then the last thing here is the number that's hanging out outside. That is, they're going to call, well, I'm calling that your K value, okay? But remember, kind of the same thing with your H value. This is on the outside, okay? And this controls your movement up and down. Just not stretching, just again, up to, down to, that kind of a thing. Okay, so this is controlling your vertical shift. So this is going to make your graph go up. If it's positive, it'll go up. If it's down, it'll be minus. So if that number were to be a -5, all it's going to do is make your graph, your trig graph go down 1, 2, 3, 4, 5 units. We're describing transformations here, so again, keep in mind, this is a lot to take in, but color coding will definitely help you. Again, if you were to write the problem down on your paper and then highlight or something, definitely worth it. All right.